Okay, number 9. Define a cyclic group. So what's a cyclic group? That's just a group where the entire thing is generated by a single element, right? So G is cyclic means that there is some element of G, so that that element alone, when you take all of its powers, both positive and negative powers, it's all of G, right? So G is A generated by A, which is the same as saying that it's all the powers of A. And again, both positive and negative powers. So not merely the powers of A, but also the powers of A inverse on the other side. Okay, so why does a cyclic group have to be abelian? Well, we'll start by saying let X and Y be any two elements of this cyclic group. Well, since any element of this cyclic group is some power of A, we can say then that X is some power of A, and Y is also some power of A, but a different power, probably. So then X times Y, well, what's that? It's just A to the n times A to the m. And well, that's just, an even bigger power of A, right? That's just A to the n plus m. And that's the same as, maybe I'll finish it down here. That's the same as, you can flip that around up there for sure. And that's the same as that. And that's the same as that. So it turns out that for any elements X and Y, it turns out that X times Y is the same as Y times X. So G is abelian. So notice that the key thing that this comes down to is that these are commutative, right? Because these are commutative, right? The addition in the exponent, you can swap the order of that. And that's why you can swap the order of the multiplication ultimately, right? One student said something like this, You can swap that because Z is abelian. And that's exactly right. The integers with addition is an abelian group. And ultimately, that's the reason why any cyclic group is abelian. So if that was you, that was cool. I like that. Okay, so anyway, there you go. That's why any cyclic group is abelian, because every two elements is a power of A, and you can certainly swap powers of A.